This is section 3.1, inversing addition. Let's suppose, SPSE, good abbreviation, that we have an equation that looks like this. X plus 3 is equal to 9. What we want to do is we want to find the particular value of x that makes this true. There's one number, we're looking for it. One of the ways that we could go about this would be to think of some of the sums with 3. That is to say, 1 plus 3 is 4, and keep going, and keep going, and keep adding. 5 plus 3 is 8, and then finally 6 plus 3 is 9. Aha! That's exactly what we wanted. So what does this mean? This means that x equal to 6 is our solution. But this, what we just did here, this was just a whole bunch of guesses. We were just guessing. What we want is a process. We don't want to deal with all of this guessing. We want to jump to the answer. We don't want to have to do, this was what, 6 separate additions? That's 6 too many, or 5 too many. We don't want to have to do all of that. So let's look at something here. Note that if I take 9 and I subtract 3, that gives me 6. And even better, if I take the other side of the equation, x plus 3, and I subtract 3 from that, we're left with just x. 6. X. We're on to something here. Let's solve this equation again. Remember, we had x plus 3 is equal to 9. We'll begin by rewriting it. Now, remember our thought was subtract 3. And if we look at what we had here, it was 9 minus 3, as well as x plus 3 minus 3. So what we just did here, something very important. We subtracted 3, not just from one side, but from both sides of this equation. And the result of that is, these are going to cancel. We'll be just left with x on the left-hand side. 9 minus 3 is 6. We arrive at the solution. So again, two very important things here. First, it was both sides of the equation. And this is sometimes called the golden rule. Golden rule of algebra is what you do on one side, like subtract 3, you got to do right back on the other side. Both sides have to have that operation performed on them. The other important thing to note is 3 minus 3 is 0. Right? We had 3 minus 3 over here. We were left with 0. Subtracting 3 is the inverse of adding 3. So, we had x plus 3. We performed the inverse operation on both sides, and we reached our answer. Let's do another. Take a look at the equation. X plus 8 is equal to 19. Now, we have add 8. If I was to subtract 8 from that, we'd be left with 0. But I can't just do it to this side. I've got to do it on both sides. Now I'm going to go ahead and fill in the rest of the equation about this. And I can see right here, 8 minus 8, that's 0. They cancel out. The left-hand side reduces down to x. 19 minus 8, my right-hand side is going to reduce down to 11. That's the solution there. Whenever we have something of this form, and we're going to go ahead and use some parameters. Whenever I have an equation of this form, x, and then we had plus some value, a, is equal to another value, the solution is going to have the form x is equal to b minus a. And in the textbook, this is theorem 3.1.3. Okay, let's try another example here. This time we're going to do something a little different. I'm going to take x, I'm going to subtract 6 from it, I'm going to set that equal to 3. Now, we know what we're looking for. I need a number that, when I add to -6, negative, this is of the form of adding some number here. Well, we're adding a -6. So we need a number that we add to -6 and gives us 0. So -6 plus this number is equal to 0. 6. Addition by 6 is the inverse of subtraction by 6. So I'm going to go ahead and add 6 to my left-hand side, and I'm going to add 6 to my right-hand side, and we're going to have, once we fill in the rest of the equation, let's see here, x minus 6 plus 6, minus 6 plus 6. They cancel out. They give us 0. So our left-hand side reduces down to x. And then on the right-hand side, we take 3, we add 6 to it, we're left with 9. That's our solution. Okay, that's it for section 3.1.